All right, the next set of problems that we're going to look at involves linear equations in two variables. On the final review, this is problems 5 through 12. All right, so problem number 5, we're going to talk about graphing linear equations. We want to label at least 2 points on the graph. There are two techniques that I'm going to show you in order to do this. The first one is using intercepts. So we're going to plug in 0 for x and y and solve for the other variable. So for example A, I'm going to go ahead and create a table. I'm going to start by plugging in 0 for y. If we plug in 0 for y, my y term goes away. I can divide by 4, and I am left with x equals 2. So 2, 0 is my x-intercept. This is where the graph crosses the x-axis. For my y-intercept, I'm going to plug in 0 for x. My x term goes away, and I can divide both sides by -2. We get y equals -4. And so 0, x is 0, y is -4. This is my y-intercept. Okay, so now let's go ahead and graph these 2 points. 2, 0, we're going to start at 0 and we're going to move 2 to the right on the x-axis. 0, -4, we want to move 4 down on the y-axis. And then we want to go ahead and draw our line. We should go ahead and label our points. So our x-intercept was 2, 0, and our y-intercept was 0, -4. And sorry, it doesn't come out looking any better than that. All right, let's go ahead and try the other method. So the other method that you can use is you can graph by rewriting in slope-intercept form. So our first step is going to be to solve for y. We want to plot the y-intercept. That shouldn't say isn't, it should say intercept. And then we want to use the slope to find a second point. From there, we're going to plot and label our points and then draw a line through the points. So for example B, if I go ahead and write this in slope-intercept form, I want to solve for y. My first thing I'm going to do is subtract 2x from both sides. We get 4y equals, I'm going to write this in I'm going to put my x term first. And then I'm going to divide by 4 to each term. If we simplify, we get -1/2 x plus 2. So my y-intercept is 0, 2, and my slope is -1/2. Remember, slope is rise over run, so this tells me to go down 1 and right 2. So if we go ahead and graph this now, we have our y-intercept is 2 above the x-axis. We're going to go down 1, right 2, and we can do this a couple times in order to get our line. All right, if we go ahead and connect the dots, this is what we end up with. So my points on the line, I have 0, 2 as my y-intercept. Another point on the line is 2, 1. And that's all you need, but if you want, you can always label a third one. Just so you can, if you want to check using the intercept method, we should get that the x-intercept is for 0. All right, so that takes care of graphing, linear equations. Let's go ahead and see what else we're going to be required to do. All right, problem 6, we want to calculate the slope and then state whether the line is increasing, decreasing, vertical, or horizontal. So remember that we have to use our slope formula. Our slope formula is m equals y2 minus y1 over x2 minus x1. We subtract our y coordinates over subtract our x coordinates. So for example A, if we go ahead and calculate our slope, we get m equals, I'm going to go ahead and label my points, x1, y1 and x2, y2. We get 2 minus -1 becomes +1 over, subtract my x coordinates, we get 3 minus 0. This is equal to 3 over 3. We should simplify completely. This gives me a slope of 1. Okay, is this line increasing, decreasing, vertical, or horizontal? This is an increasing line. And why is that? It is increasing because the slope is positive. All right, let's try a couple more. B. Again, I'm going to label my points, x1, y1, and x2, y2. If we plug in, we get m equals 2 minus 7, subtract your y coordinates, over, subtract your x coordinates. We get -1 minus -2 becomes +2. If we simplify, we get -5 on top, 1 on bottom, and so our slope is equal to -5. Okay, is this line increasing, decreasing, horizontal, or vertical? This is a decreasing line. Because the slope is negative. Okay, last one. We label our points. And we plug into our formula. So we get m equals -3 minus -3 becomes +3 over 5 minus 9. If we simplify, we get 0 over -4, which is equal to 0. Remember, if 0 is in the bottom, it is undefined. If 0 is on top, it is just 0. So what kind of line do we have here? This is a horizontal line. I can walk on a flat surface. Undefined is a vertical line. I cannot walk up the wall. That is undefined. And why is this a horizontal line? Because the slope is 0. All right, so that is calculating slope. The next thing we want to do is we want to identify slope and y-intercept and write equations in slope-intercept form. We did this on problem number 5 a few problems ago. We're going to go ahead and do it again just to kind of review. So remember that slope-intercept form is y equals mx plus b. So for problem 7, we have, given the linear equation 3x plus 5y equals 8, we want to start by writing the equation in slope-intercept form. That means solve for y. We're going to start by subtracting 3x from both sides. We get 5y equals, again I'm going to put my x term first so that it matches up with my slope-intercept form. And then we divide by 5 to each term. So my part A, we have y equals negative 3/5 x plus 8/5. For part B, what is our slope? We have m equals negative 3/5. Make sure that you just keep the number. There is no x in slope. So just the coefficient. And C, we do want to be careful. Make sure that you put the y-intercept in point form. Point form, what does that mean? It means I want 2 coordinates. So 8/5 is my y-intercept. Is it the first coordinate or the second coordinate? Well, since it is a y value, it is going to be the second coordinate. My first coordinate is going to be 0. Okay, so that takes care of 7. Let's try another one. We have the equation 2x minus 4y equals 12. We're going to do the same thing. So I want to start by writing in slope-intercept form. I'm going to subtract 2x from both sides. I want to rewrite this with my x term first, so we're going to get negative 2x plus 12. And finally, to get y by itself, I divide each term by negative 4. So we get y equals, we want to simplify. My negatives cancel, and if I simplify the fraction, I get 1/2 x. 12 divided by negative 4 is negative 3. Okay, for B, we want to know what is the slope. We're going to keep the coefficient of the x term, so it's going to be 1/2. And our y-intercept in point form, x is 0, y is negative 3. Okay, that takes care of going back and forth between or translating into slope-intercept form for these problems. All right, let's go ahead and do a couple more. The next one, this is a very straightforward problem, hopefully. This is write the equation in slope-intercept form given, and pay very close attention to this part, we are given the slope and the y-intercept. So there is no actual work to this problem. This is just plugging in the information. So we're even told m equals negative 2. So I'm going to replace m with negative 2. And b is my y-coordinate of the y-intercept, so we get negative 2x plus 3. And you're done. Don't do any more. Okay, problem B, let's try it again just to see how easy it is. We plug in 3 for our slope, or m, and we plug in negative 2 for our b, so we get y equals 3x minus 2. All right, so that's given a slope and a y-intercept. Now the next problem, what happens if it's not a y-intercept? So I'm going to show you 2 ways to do this problem, and then depending on how good your memory is, you can decide which one you like better. So for this problem, we want to write the equation of the line in slope-intercept form given the slope and a point that lies on the line that is not the y-intercept. So the way that we did this originally was we used the point-slope form for the equation. And the point-slope form is y minus y1 equals m times x minus x1. So we're going to go ahead and do this for problem A. I'm going to write out my formula again. I'm going to label my coordinates. This is going to be my x1, y1. And when we plug in, we get y minus my y-coordinate, which is 3, equals 4 times x minus my x-coordinate, which is 5. Okay, so we go ahead and now we want to rewrite in slope-intercept form. So we're going to start by distributing. We get 4x minus 20. And finally, to get y by itself, we add 3 to both sides, and we get y equals 4x minus 17. Okay, so that's the way that we learned it originally. Now, as this is the final and you are not allowed a cheat sheet or notes or books or anything like that on the final exam, I'm going to show you another method that you can use, and that is using the slope-intercept form. So if we decide to use the slope-intercept form, we're going to start by plugging in for m, x, and y, and then solve for b. Now this is a 2-step process. Once we have b, we do need to go back and plug in the information back into our slope-intercept form. Let's do that for b. So we have our formula that if you only know one of them, this is the one to know. So I'm going to plug in for m, x, and y. So we get y is 2 equals negative 6 times x is negative 1 plus b. If we solve for b, we're going to multiply negative 6 times negative 1. That gives me 6. And then to solve for b, we're going to subtract 6 from both sides. We get negative 4 equals b. Now, this is not the answer, because remember that originally it said write the equation of the line in slope-intercept form. So now what we need to do is take our negative 6 and our negative 4 and plug it back into our formula. So we get y equals negative 6x, our m value is negative 6, minus 4, our b value is negative 4. All right, so that's the second method that you can use on these. So pick which one you like best and try it for the other problem to make sure that you know how to do this. Okay, then we get to the really fun section, which was systems of equations. Don't worry, we don't have a lot of problems for system of equations, but we do have some. So this, we're going to be told we can use either substitution or elimination method. I'm going to show you both. And again, pick one that you like best and stick with it. So for example, so let's review what substitution and elimination method are. Substitution, we want to solve for a variable and plug into the other equation. Elimination method, we're going to multiply one or both equation by numbers so that the coefficients are the same with opposite signs. So for instance, 4 and -4. We do this so that when we add straight down, they cancel. Okay, so let's look at example A. Example A is set up for elimination method, and substitution method's not bad on this one either. Remember that if you're going to do substitution method, always pick a variable that has no coefficient to make it easy on yourself. I'm going to go ahead and do elimination method on this, and I want to eliminate the y. So in order to eliminate the y, I already have different signs, so we're good there. I do want same coefficients. So in order to do that, I need to multiply by 4. So if we do that, my first equation stays the same. My second equation, when I multiply by 4, I get 20x plus 4y equals, I want to say 104. I think that's right. All right, so elimination method, what we do is we're going to add straight down. We get 27x. My y's cancel, and we get 108. If we divide by 27 now, I get x equals 4. And this is just the x coordinate. We still need to find the y coordinate. So I'm going to plug it back into one of my original equations. I'm going to go with the second one. Y, because I can. Note it does not matter which one you work with. We get 5 times 4 is 20, plus y equals 26. Subtract, we get 20. Subtract 20 from both sides. And we get y equals 6. So my solution is 4, 6. All right, let's look at example B. Example B, this is set up for substitution method because I have y by itself. So we already have solved for y, we can go ahead and proceed. Now, the one on the final exam should be set up for either or. It should not be leaning in favor of one of them. So this one, I'm going to go ahead and show you substitution method. So substitution method, we already have the first part done. We have y equals -15 minus 4x. So I want to take the -15 minus 4x and plug it into my other equation. So if we do that, we get 3x minus 5 times y. Y we said is -15 minus 4x equals -17. All right, we want to go ahead and distribute. We get -5 times -15 is 75. and we get negative 5 times negative 4 is plus 20x. I can combine my like terms. 3x and 20x is 23x. And I can subtract 75 from both sides. We get 23x equals negative 92. Divide by 23 to both sides, and we get x equals negative 4. All right, so we get x equals negative 4. The rest of this is going to be the same as the last problem. We want to plug it into one of our original equations. I'm going to go with the second one again, because I can. And if we simplify this, we get negative 15. Negative 4 times negative 4 becomes plus 16. And negative 15 plus 16 is 1. So my solution is negative 4x, comma y, negative 4, 1. All right, so those are some basic substitution or elimination problems. Now let's look at some application problems. Okay, so the first one we have, a restaurant manager buys 50 pounds of sausage and 80 pounds of hamburger for a total of $300. Let's go ahead and, let's keep reading it. Second purchase at the same price includes 100 pounds of sausage and 120 pounds of hamburger for a cost of $480. We want to find the cost of sausage and the cost of hamburger. So I'm going to let S be my sausage. I'm going to let H be my hamburger. So my equations, we're going to have 50S plus 80H equals 300. We're going to cut this into two sentences. The first one, we have 50 pounds of sausage and 80 pounds of hamburger. We're going to add up the cost for both of those, which will equal our total cost of 300. Okay, second sentence, it says, a second purchase at the same price includes 100 pounds of sausage and 120 pounds of hamburger, totaling $480. Now we can go ahead and solve using either substitution or elimination. I'm going to go ahead and use elimination method on this one. I'm going to multiply the first equation by 2 so that we can eliminate the S. And I'm actually going to multiply by negative 2 because we do need different signs. So if we do this, we get negative 100S minus 160H equals negative 600. My second equation is going to stay the same. And if we go ahead and add straight down, my S terms cancel. I am left with negative 40H equals negative 120. We can divide by negative 40, and we get H is equal to $3. Remember, what are we looking at? We're looking for the cost. This is $3 per pound for hamburger. Okay, let's go ahead and calculate the sausage. So I'm going to go ahead and plug this into my top equation. We get 50 times S plus 80 times 3 equals 300. If we simplify, we get 50s plus 240 equals 300. I can subtract 240 from both sides. And we get 50s equals 60. If we divide by 50, we get S equals, I believe this comes out to $1.20 per pound for sausage. Okay, last problem for this section. We have, if David has 39 bills in his wallet worth $330, all 5s and 10s. We want to know how many of each bill does he have. So I'm going to let F equal the number of $5 bills. And I'm going to let T equal the number of $10 bills. So the first thing we have is, I know that we have 39 bills. So my first equation is going to be the number of 5s plus the number of 10s is equal to 39. The second piece of information, we have what they're worth. We have they're worth $330. So to figure out how much money we have from the $5 bills, I'm going to multiply 5 times the number of bills we have. To figure out the amount we have for the $10 bills, I'm going to multiply 10 times the number of $10 bills. And if we add that together, we will get the total amount that we have available, which is $330. Okay, so this is set up for substitution or elimination method. Again, it's up to you what you want to do. I'm going to go ahead and do elimination method on this. So the first thing that I want to do is I want to solve for one of my variables in my top equation. I'm going to solve for F. Again, it doesn't matter. The reason I am picking F is because the coefficient in the second equation is smaller. So that means that I won't have to worry about negatives. So we get F equals 39 minus T. If we plug this into our other equation, we get 5 times 39 minus T plus 10T equals 330. We go ahead and distribute. 5 times 39, I get 195. Yes. Minus 5T plus 10T equals 330. We combine our T values, or our T terms. We get 5T equals 330. We can subtract 195 from both sides. We get 5t equals 135. If we divide by 5 now, I get t equals 27. So we have 27 $10 bills. All right, to figure out the 5s, I'm going to go ahead and plug this back into my first equation. So we get f plus 27 equals 39. We can subtract 27 from both sides, and we get f equals 12 $5 bills. All right, we're done with our linear equations in two variables. The next thing that we will be looking at is polynomials. So hopefully that'll make you feel a little bit better after this section. All right, so go ahead, take a quick break, and then we'll come back.